Okay, so 7.3 special products of polynomials. So example 1, find each product. So we have in example 1a, we have 3x plus 4 in parentheses squared. And the number one biggest mistake is taking, and I don't even want you to write this down because it's a mistake, it's not correct. So the biggest mistake that I see people make is making the 3x squared and then making the 4 squared, but that is not right. It's not going to get you to the right answer ever. And you may be thinking, why? Like, we learned a property like that when we were in chapter 6, but that property doesn't apply when you have multiple terms inside the parentheses. That only applied to monomials. So we have 1, 2 terms inside the parentheses, so I can't use that property. It only works when it's just a bunch of different factors of one big product inside the parentheses. So what this is saying, the 3x plus 4 in parentheses squared, that means 3x plus 4 times itself twice. So 3x plus 4 times 3x plus 4. And then now this looks a lot more like a problem that we've done before throughout the rest of the chapter, where we need to FOIL it or use the table or use the distributor property. But the biggest thing is getting from here to here and knowing that 3x plus 4 squared means the whole thing written out side by side. So now that we have it set up to where it's 3x plus 4 times 3x plus 4 twice, we can go ahead and FOIL. So remember, FOIL is first, outer, inner, last. So if I multiply the first term in each parentheses, that's 3x times 3x. So we'll multiply the 3's. 3 times 3, that's 9. And then if we multiply the x's, x times x is x squared. So 3x times 3x, it becomes 9x squared. And then if we multiply the outer, that's 3x times 4, the factors on the very outside of my expression. So 3x times 4 is 12x. And then if I multiply the inner 2 terms, the ones that are on the very inside of my expression, 4 times 3x, that becomes 12x also. And then if I multiply the last term in each parentheses, this becomes 4 times 4, so that's 16. So plus 16 at the end. And then remember, the next thing that we always have to do is just make sure that we check for like terms. So I have a 12x and a 12x that are both x to the first power. So I can combine those because they have the same variable to the same exponent. So I'm going to bring down my 9x squared. I can combine the 12x and the 12x. I just need to add the coefficients. So 12 plus 12 is 24. And then when we combine like terms, the variable doesn't change. The variable in the exponent doesn't change. So 12x plus 12x just becomes 24x, and then I'll bring down my plus 16. So altogether, 9x squared plus 24x plus 16. And then for B, 5x minus 2y squared. It's the same thing. I can't just take that squared and distribute it in because there's multiple terms inside the parentheses. So I have to write the whole thing side by side because it's 5x minus 2y being squared. And that means 5x minus 2y times 5x minus 2y. And then because we have a binomial times a binomial now, we'll go ahead and FOIL it. So by FOILing it, the S stands for first. The first term in each parentheses times each other. So 5x times 5x, I'll multiply the 5s together, that becomes 25. And then x times x, that's x squared. And then the O in FOIL stands for outer, so I have to multiply the terms on the outside of the parentheses. So the 5x times the 2y times the negative 2y. So I'll multiply the 5 times the negative 2, that's negative 10. And then x times y, those aren't like the same variables or anything, so I can't combine them and add their exponents. We just write that as x, y. So I'm going to rewrite this kind of up here just to show you. 5x times negative 2y. I know that I can multiply the coefficients together. 5 times negative 2, so that's negative 10. But x and y, I can't combine those really because they're different variables, so they just get written side by side. And then when I go to multiply the inner two terms, this is negative 2 times negative 2y times 5x. So I can multiply the negative 2 times the 5 again, that's negative 10. And then I'm multiplying the variables y times x or x times y, so that can be written as xy as well. I can write it like yx, I can write it in the other order. It just sometimes gets confusing when we don't keep the order consistent because that makes it look like these aren't like terms, but they are like terms because they have the same exact variables to the same exponents. They just happen to be written in a different order. So I'm going to leave it as 10xy. And then the O in the L in FOIL stands for last. So I have to multiply the last two terms in each parentheses. So negative 2y times negative 2y. Negative 2 times negative 2 is positive 4. And then y times y is y squared. And then from there, we just want to check for like terms. So I have a negative 10xy and another negative 10xy that both have x to the first power and y to the first power. So that makes those like terms. So we can combine those and just bring down every other term. So 25x squared. When I combine the negative 10xy and negative 10xy, remember I'm just combining their coefficients. So negative 10 and negative 10 together is negative 20. And then the xy stays the same. And then I have to bring down my plus 4y squared. So 25x squared minus 20xy plus 4y squared. And then these two are for you guys to practice on your own. So for A, it's x plus 7 squared. And for B, it's 7x minus 3 squared. I'm going to leave these examples up at the top so you have those to go off of if you need them. So I'll probably give you guys probably about 3 minutes to work through these, and then we'll go through them together. Okay, so for A, for x plus 7 squared, or x plus 7 in parentheses squared, remember that your very first step when you have a binomial like we have, like just the x plus 7 part that's a binomial and it's being squared. So our very first step should be writing it side by side, like writing it completely out instead of in terms of being squared. So that looks like x plus 7 times x plus 7. It's just that binomial multiplied by itself. And then from there, because we have a binomial times a binomial, we have to FOIL it. So if I FOIL it, I have to multiply the first two terms together. So the first term in each parentheses is x and x. So x times x is x squared. And then I have to multiply the outer two terms together. So the outside terms are x and 7. So x times 7 we write as 7x. And then I have to multiply the inner terms together, which is 7 times x. So we write that as 7x. And then I have to multiply the last two terms together, which is 7 and 7. So 7 times 7 is 49. So plus 49. And then after we FOIL, we always want to check for like terms. So I have a 7x and a 7x that both have x to the first power, which means I can combine them by adding them together. So every other term is going to come down. So the x squared, that comes down. 7x plus 7x, I just add the coefficient. So 7 plus 7 is 14. And then that variable stays the same. So 14x, and then I'm going to bring down my plus 49 because that's my only constant term. So x squared plus 14x plus 49. And then for B, 7x minus 3 squared. So same thing, we want to write it side by side. 7x minus 3 times 7x minus 3. So it's just the same binomial repeated. And then from there, we'll FOIL it. So FOIL will multiply the first term in each parentheses together. So in this case, it's 7x times 7x, which 7 times 7 is 49. And then the x times x becomes x squared. And then we'll multiply the last term in each parentheses together. So 7x times negative 3. So 7 times negative 3, that's negative 21. And then I'm not multiplying another x, or not multiplying any x's together, so that x just stays the same. So 7x times negative 3 is negative 21x. And then we'll multiply the inner terms together. Negative 3 times 7x, so again, that's also negative 21x. And then the last terms together, negative 3 times negative 3, which is positive 9. And then always check for like terms. I have a negative 21x and another negative 21x that both have x to the first power, which means we can combine them. So I'll bring down my 49x squared. Negative 21x and negative 21x together, if I combine those, the negative 21s together become negative 42x, and then plus 9. So 49x squared minus 42x plus 9. And before we move on to the next section, I just want to bring this up. Once we get to this point where we have several different types of terms and they all have like different variables or different exponents over the variables, that's as simplified as your answer can be. So I'm not going to try to combine my 49x squared and my 42x because those don't have the same exponents over the x. So that means that I can't combine them by just addition anymore. So my problem is as simplified as it can be. Okay, and then example 2, this is just another kind of specific type of, I guess, FOILing problem. We're still going to go about it the same way, but the answer may look a little bit different than our previous answers. So find each product. For 2a, it's t plus 5 times t minus 5. So we still have a binomial times a binomial. So whenever we have a binomial times a binomial, we FOIL it, or if you're using the table method, you can use the table method. So if I go to FOIL it and then multiply the first term in each parentheses, t times t, that's written as t squared. And then if I multiply the outer term in each parentheses, t times negative 5 is negative 5t. And then if I multiply the inner two terms, 5 times t, or positive 5 times t, so that's plus 5t. And then if I multiply the outer two terms, or sorry, not the outer two, the last two terms for L, 5 times negative 5, that becomes negative 25. And then from there, we need to check for like terms. So negative 5t and positive 5t. I think if I have a negative 5 and a positive 5, those are like kind of like opposites of each other, or like a negative 5 plus positive 5 would just be 0. So they just kind of cancel each other out, just like 2 and negative 2, or 4 and negative 4. They're just completely opposite. So if we add them together, they become 0, or they just completely cancel out. So that means I just have to bring down my t squared and my negative 25. Because the t to the first power terms undid each other, they just cancel each other out. So if we backtrack a little bit and look at the way this problem was set up initially, we can kind of start to make sense of like why our answer looks a little bit different. So if we go back to the original problem, I had t plus 5 and t minus 5. So they were almost the same. The only thing that changed was that plus and that minus. So that's what caused that 5t and the negative 5t to just cancel each other out. So this is another special type of pattern. So this says, like up at the top, says using the sum of difference pattern. You may see it referred to as like the difference of squares once we get into factoring. But just keep in mind, this is just another like special type of product. But the way we go about finding that product doesn't change, and we're still foiling. And then for B, we have 3x plus y times 3x minus y. So it's in that same kind of pattern where it's 3x plus y and then the same 3x, but this time it's minus y. So the only thing that's changing is this plus and this minus are just flipping. So if we want to find our product, though, we just still need to FOIL. So we'll multiply the first term in each parentheses, 3x times 3x. So 3 times 3 is 9, and then x times x is x squared. And then if I multiply the outer terms, 3x times negative y. So it's a positive times a negative, so I know that product will be negative. And then, but 3x times y, I can't really like combine the x and y together. I just write them side by side. So that's negative 3xy. And then when I multiply the inner terms together, y times 3x. So same thing, I can't really like put the x and y together. I can write them side by side. But this time it's a positive y times a positive 3x. So this should be plus 3xy. And then when I multiply the last term in these parentheses, y times a negative y, it's negative since it's a positive times a negative, and then y times y is y squared. So 9x squared minus 3xy plus 3xy minus y squared. And then we want to check for like terms. I have a negative 3xy and a positive 3xy. So if I have negative 3 and positive 3, when I add those together, I just get 0 because they're opposites. So like negative 4 and positive 4, like we talked about with A, or negative 5 and positive 5, like we talked about in part A. So they just completely cancel each other out. It's like if I start with a balance of negative $3 and then I put $3 in my bank account, I now have $0 in my bank account. So they just undo each other. So they cancel each other out, and then I can bring down my other terms, 9x squared, and then minus y squared. So 9x squared minus y squared. And then just keep in mind, anytime you have a pattern or a problem that falls within this particular pattern, where they're the same exact numbers, 3x and 3x, or terms, y and negative y, The only thing that changes is this plus and this minus. You're going to end up having those middle terms cancel out. So that could be a good way for you to just kind of do a mental check in your head once you finish the problem. Okay, so you guys have these two problems to practice on your own. I'm going to give you a few minutes to work through those, and then we'll work through them together. Okay, so for A, we have x plus 10 times x minus 10. So it's definitely falling under that same pattern that we were talking about where it's basically the same binomial with x and 10. The only thing that changes is one is a plus 10 and one is a minus 10. So that kind of gives us an idea of what our final answer may look like, at least for us to kind of like check and see if there's anything that might have went wrong. So we still figure it out. We still find the product the same way. We're going to FOIL. So we'll multiply the first term in each parentheses, x times x, that's x squared. And then we'll multiply the outer term in each parentheses, x times negative 10. We write that as negative 10x. And then we'll multiply the inner term in each parentheses, which is now a positive 10 times x. So we write that as plus 10x. And then we'll multiply the last term in each parentheses, which is a positive 10 times a negative 10, so negative 100. And then from there, we'll check for like terms, negative 10x and positive 10x. So a negative 10 and a positive 10, those just kind of cancel each other out. So kind of like the bank account thing we were talking about. If you owe someone $10 and then you pay them that $10, then you're just break even. So those undo each other, they cancel each other out. I can bring down the x squared. The negative 10x and positive 10x go away. and then I can also bring down the negative 100. So x squared minus 100. And then for b, same thing. We have a 2x and a 1, a 2x and a 1. The only thing that is changing is the plus and the minus. So we know that there's some things that are going to cancel out for our final answer, so we can keep that in mind. And then we can just stick with boiling it. So x times x, or sorry, not x times x, but 2x times 2x for the first term in each parentheses. 2 times 2 is 4, and then x times x is x squared. And then when I multiply the last term in each, the outer term in each parentheses for the O, 2x times that negative 1 is negative 2x. And then when I multiply the inner term in each parentheses, this is a positive 1 times 2x. So positive 1 times 2x would be positive 2x. And then when I multiply the last term in each parentheses, a positive 1 times a negative 1 is negative 1. So 4x squared minus 2x plus 2x minus 1. We'll check for like terms. I have a negative 2x and a positive 2x. So that negative 2 and positive 2 add up to 0, so they cancel each other out. And then I can bring down my final two terms, 4x squared minus 1. Okay, so I'm going to leave this up for a second longer, and then we'll move forward to our next thing for today.